Hello, good morning, sir. So today, myself, then Wafi, Azizul Hakimi, Atika Rizwan, we will be presenting about our assignment title, which is Synchronization Symbol Timing Estimation. So we are from Group O. So moving on to the first slide, which is about introduction about the synchronization. So what we would like to tell is a short brief. So we know that there are levels of synchronization that are necessary in a complex communication system. So in a digital communication system, timing synchronization plays an important role in recovering the original message that has been transmitted. The demodulator's output must be sampled at the symbol rate at exact sampling time instance on a regular basis. So here we have the mathematical model, which is Tm equals to m times t plus tau, where the capital T is the symbol interval while tau is the time delay, which account the propagation time of this signal from T transmitter to receiver. So for the next, it is important to have a clock signal in order to perform periodic sampling, and the process of extracting the clock signal is called symbol synchronization or time recovery. So in short, symbol timing synchronization is a method of estimating the receiver clock that is aligned in both phase and frequency with the transmitted clock. So for the next slide, I will pass it to Wafi.
Alright, hi sir. So now I will explain about timing recovery. So timing recovery is one of the most important task performance at the receiver of synchronized digital communication device. Not only does the receiver need to know the frequency, which is 1 over T, at the which the output of the mesh filter or correlated or sample, but it also need to know where a sample should be taken during each symbol interval. The timing process is pretty well defined as the selection of sampling instant with it a symbol interval of during t. Alright, next slide. Okay, now before we go further to the type of estimation method used, let's recall back the function of symbol synchronization. Its function to collect the clock signal for sampling by using a narrow band filter tuned to the transmit lock frequency. That's happen is in receiver. Okay, through its simplicity in implementation, the transmitter have to allocate some of its power and some part of the channel bandwidth to the transmitter clock signal. Okay, this approach is commonly used in communication network that use wide bandwidth to relay signal from large number of users. Next, the propagation of clock signal is shared among the many user in situation as is the demodulation of signal. The penalty of transmitter capacity and bandwidth transmitter is equal to the number of users, thus it's the mutual use of the clock signal. Okay, now I will pass to Rizwan. Thank you.
Okay, Assalamualaikum and very good evening, Dr. Adam. Okay, now I would like to explain for the maximum likelihood timing estimation. So, there are numbers of study where timing recovery algorithms are generated. These algorithms are commonly simulated in MATLAB for symbol synchronization techniques. These algorithms represent a complete wireless communication system that involves a transmitter, an AWGN channel including relay, fading, and a receiver. The number of filters and feedback loops in the wireless system are reduced as much as possible to decrease the processing time and reduce the complexities of the communication system. So we have the maximum likelihood timing estimation. And if the signal is a baseband pulse amplitude modulation waveform, so we can obtain an algorithm as shown below. So as in the case of maximum likelihood phase estimation, we distinguish between two types of timing estimators, which are decision-directed timing estimators and non-decision-directed estimators. Okay. So now I would like to explain about the decision-directed timing estimators. So the information symbols from the output of the demodulator are treated as the known transmitted sequence. So in this case, the log likelihood function the algorithm can be obtained as the below algorithm or below equation. Thus, after simplified the algorithm or equation, so we can obtain it by seeing the second algorithm. Okay, next. Okay, below are the block diagram of decision directed maximum likelihood estimation of timing base for baseband pulse amplitude modulation. So it is worth noting that the summation in the loop acts like a loop filter with the duration of the sliding windows in the summation controlling the bandwidth. The output of the loop filter drives the voltage control clock, or also known as VCC, or voltage control oscillator, which controls the sampling times for the input of the loop. Since the detected information sequence is used in the estimation of tau, then the estimate is a decision directed. So next, I will pass for non-decision directed timing estimation for Azizul Hakimi to explain.
Hello and Assalamualaikum and good evening. So by averaging the probability ratio over the knowledge symbol to obtain and then differentiating, a non-decision directed timing approximation can be obtained. When the symbols are unknown, we average the likelihood function over the symbol distribution. Suppose the transmitted signal is binary pulse amplitude modulation, as shown in the equation below, where the bi are equally likely to be plus minus 1. The maximum likelihood estimate of tau is obtained by maximizing the average of the log likelihood function, where as shown as the equation below, both of the equation below. Okay. An implementation of the tracking loop based on the derivative of is shown as the following plot diagram below. Okay. Alternatively, an implementation of the tracking loop based on is shown as the plot diagram below with the equation. In both structure, we observe that the summation serves as the loop filter that drives the VCC. For early late gate synchronizer, consider the rectangular pulse ST. At this condition, and the output of the filter match to the ST attain its maximum value at time tau equal to time. Thus, the output of the match filter is the time autocorrelation function of the pulse. It will, of course, be used on any signal pulse. Clearly, the proper time to sample the output of the match filter for the maximum output is at tau equal to time. For example, at the peak of the correlation function. In the presence of noise, the identification of the peak value of the signal is generally difficult. Since the autocorrelation function is even with respect to the optimum sampling time tau equal to time, then it's shown as the equation below. Under this condition, the proper sampling time is the midpoint between tau equal to time minus by delta and tau equal to time plus delta. This condition forms the basis for the early late gate symbol synchronizer. So this is the block diagram for early late gate synchronizer. For symbol synchronization, I will pass to Wafi.
Alright, thank you for Azizul. Okay, now let's do some quick tests. Okay, in this below have a two answer to represent symbol synchronization. What the answer the true? A is the transmitter and receiver clock in certain communication system are synchronized to a master clock, which give a very accurate time signal. Or B, the receiver must estimate the compensate for the relative time delay between transmit signal or receiver signal. What your answer, guys?
I think the answer is A.
A.
Nope, I'm
Another.
guessing the answer is B.
Okay. Okay, thank you for your feedback. So let me explain the true answer. The true answer is B. Because why? The receiver must be approximate and adjust so that there will be not time difference between the broadcast and receiver signal. For example, a radio transmission network operating in the very low frequency, which is VLF band, below 30 kilohertz, where specific clock signal a broadcast from master radio station. For transmitter, we will simulate transmit the clock frequency, which is 1 over T, or multiply of 1 over T along with the information signal. Okay, now I will pass to Atika.
Okay, Assalamualaikum and hi, good day everyone. My name is Atika and I will be presenting about the impact of the symbol timing estimation method towards the environment and the society. So from the result of our finding, we realized that synchronization system is the heart of the overall OFDM system. Then the effect of carrier frequency and timing errors are different over different channels, and it is very important to study this effect before we're going to set up the OFDM link. For society, there are demands in wireless applications such as digital audio broadcasting, DAB, and wireless LAN, where there is a need to get a higher performance of acceptable reception quality. The application like wireless LAN, cross synchronization may be sufficient, while in digital video broadcasting, fine synchronization is necessary to correct the residual errors after cross synchronization. As discovered in a study of implementation of symbol timing recovery for estimation are actually resulting energy saving, as it diminished the quantity of message transmitted. And lastly, the application of this synchronization is when it is properly being done, we could actually minimize the communication collision to occur and avoid retransmissions. Next. So for the conclusion, the significant cost of the increased need for bandwidth and service efficiency, symbol synchronization strategies have grown in popularity. Due to increased noise and Rayleigh fading, wireless networking devices faces some challenges. Additional components added to improve wireless systems can increase the wireless communication processing time and computational complexity. That is all from our group study, and these are the reference we use for this group study. And that is all from us. Thank you.
Thank you.